that in the format separating k. So value of k I have found out this much. Then if you differentiate this with respect to s, dk by ds, and equate it to 0, see here, this is u by v method you have to use in a differentiation. That is u into differentiation of v minus v differentiation of u, and then you get one second order equation, and by that one feasible coordinate you will get, that is minus 3.4. Minus 3.4 is the breakaway point. Other 2 points will be there which will not be significant. Then intersection with the imaginary axis. If you want to find out the next rule, that is intersection with the imaginary axis, same previous equation we have taken 1 plus g of s h of s equal to 0 and separated in terms in the order of s, that is s square plus 2s plus 2, and separated in the order of s, that is s square plus k plus 2 into s plus 2k plus 2 is equal to 0. Then I arrange the routes array, that is highest term is s square, so 1, leave this, write next 2k plus 2, below that s to the power 1, the remaining term k plus 2, then this is 0, only 3 terms are there, so the fourth term will be 0 only. So this multiplied by this minus this multiplied by 0, that is 0, divided by this, it will become 2k plus 2. So here if you see the first column of the Roth's array, first thing is k plus 2 should be equal to 0. If the k plus 2 equal to 0, then this becomes an auxiliary equation. So to become that, k plus 2 is equal to 0 means k is minus 2. So it is meaningless. Reason is we are drawing the root locus when k is changing from 0 to infinity, only positive values. So here it giving you negative value, that means it is a meaningless. Second, you put k plus 2 is equal to 0. If you put k plus 2 is equal to 0, in that case k is minus 2. Once again you will get a minus value. So what does it indicate? That means you are not getting any feasible values of k in the system. Feasible values of k will be only positive, that is between anything between 0 to plus infinity, plus 0 to plus infinity. So k has to be always positive. In that, then only we are plotting the root locus. Root locus means what? We are plotting the roots by changing the value of k from positive 0 to positive infinity. If you are getting the value of k negative means, that means we are not bothered about them at all, because negative values of k we are not plotting. When the negative values of k's are there, system is going to be unstable only. So that question does not come into the picture. So what does it indicate? The interpretation of that is there is no feasible value of k where the root locus cuts the imaginary axis. That means root locus will never cut the imaginary axis. So from that you have to interpret that as the feasible value of k is not available for intersection of root locus with the imaginary axis, hence you have to assume, interpret that as the root locus will not cut the imaginary axis. So all other problems so far we have seen 3-4 problems which we have seen earlier, where everywhere the root locus was cutting the imaginary axis. But here in that case you are getting positive values of k. Here we are not getting any positive values of k. Hence the root locus will not cut the imaginary axis. That means there is no root locus on the right hand side of the S plane. That is the thing, that from this only you will come to know the system will be always stable only. Then last point, we have to calculate angle of departure and arrival. See here, there are 1, 0 and 2 poles are there. That means both, so far in earlier problems there were no zeros. So we have not calculated angle of arrival. Here you have to calculate angle of arrival also, angle of departure also. So for that purpose, see here what I have done is, I have first calculated angle of departure for one of these complex conjugate root, because there is no need of finding both the complex conjugate roots angle, because if here the angle is positive, here the same angle will be there with a negative value, because it has to be symmetrical about the real axis. So the angles of complex conjugate poles and zeros have to be always same but opposite in sign. So sum of angle of zeros minus sum of angle of poles is equal to 180. So I will connect this pole. Now I am calculating angle of departure first. I am joining this pole to this pole and this pole to this pole. This is by mistake I have drawn this line. It is not required. So here to here this angle I want to find. In how to find out this? It is tan inverse of imaginary part divided by tan inverse divided by real part. Imaginary part is this one, vertical distance. The coordinate of this pole is -1 plus j. That means plus 1j is there. So this distance is 1. So this distance is 0, this is 0, this is 1, because x distance is -1 and this is -2. So the distance between this and this is 0, this is -1, this is -2, means this distance is 1. So 1 upon 1, tan inverse of 1 upon 1, this is angle of 0. Whereas angle of this pole, if I join a vertically downward line, that will be 90 only. See, if you draw a horizontal line, this will be 90 degrees, because it has tan inverse of imaginary part is 2, 1 plus 1, 2, divided by real part. Both the poles are at the same spot. That means real part is 0. So anything of tan inverse of infinity means it is tan inverse of 0 means infinity, 90 degrees. Tan inverse of 90 means infinity means 90 degrees. So 90 I have added, and phi d for this pole, that is angle of departure of this pole. So this is 45, this is 90, this is phi d is equal to 180. If I take it on this side, so it is this is plus 45, this is minus 90, means it is minus 45. Minus 45, if it comes on this side, it will become plus 45. Minus phi d is equal to 225. So phi d is equal to minus 225 and 1 is plus 225. That is what it means. Now, next is angle of arrival. To calculate angle of arrival, I will connect this 0 with this and this. So this angle I have to measure, this angle I have to measure. This angle is already measured, that is 45 degrees. So this angle, and there is no other 0, so phi A I will write here. That is angle of arrival minus this is 45 and then this is minus 45. So if you add it, one becomes 45, another becomes minus 45. So this becomes 0. It will be equal to 180 degrees, not 90 degrees. 180 degrees means horizontal line. By mistake, I have written it as 90 degrees. See, this is this is plus 45. This is minus 45. Plus 45 minus 45 is 0 only. So 0, that means phi d is equal to 180 or minus 180 degrees. So phi d is equal to plus minus 180 means same line. So there will be horizontal departure. After that, I will plot the root locus. See here, the root locus will not cut the imaginary axis. So nothing goes towards the imaginary axis. The root locus always starts at a pole. One root locus starts here. So the angle of departure for this is 225 degrees. So measure 225 degrees from this side. It is minus 225 degrees. So if you measure it like this, that is minus 225 degrees. Draw a tangent to that. That will become like this. So this is the tangent, minus 225 degrees. So this is minus 225. This will be plus 225. That's all. So plus 225 means you have to calculate all the way like this. Minus 225 means you have to calculate all the way. You have to draw a tangent and measure that angle. To that you draw a tangential curve. So the root locus will start here and it will come to a breakaway point. The breakaway point is minus 3.4. Similarly, the root locus will start here and come to this breakaway point only. That is minus 3.4. Once they meet here, one root locus will go towards this 0 because the root locus has to end to 0. So one root locus will go to minus 2 another root locus will go to minus infinity because there is no other 0. So the 0 always exists at minus infinity. So this is how the problem looks like. Is it clear? You can ask me a question based on this. Actually, this is a part of the circle only. It is like a circle only. The not full circle, part of the circle. Is it clear? Any questions on this? Because this is the different variety of the problem, where the asymptotes are not there and it is not cutting the imaginary axis. Then another problem is circle problem. This is a circle problem. You can see this g of s is given as k into s plus 1 into s plus 2 divided by s plus 0.1 into s minus 1. That is what is the problem. So in the denominator, you can see there are two bracket, means two poles are there. So P is equal to 2, one at S is equal to minus 0.1 and another one at plus 1. So another pole is on the plus 1 side. That means after the imaginary axis. This is where the K is 0. Root locus starts here. There are two zeros also. In the numerator, there are two brackets you can see. Equate them to 0 individually. S plus 1 is equal to 0 means S is equal to minus 1 and S is equal to minus 2. So there are two zeros, one at minus 1 and one at minus 2. So the number of root locuses will be equal to number of poles or zeros, whichever is higher. Both are same now. Both are equal to 2. So hence number of root locuses n is equal to 2. Then here if you see the calculation of angle of that asymptotes and all those things. See what happens is P minus Z. The denominator is P minus Z. P minus Z is P is 2, Z is 2 means 0. Denominator becomes 0 means the number of asymptotes will become infinity. The angle of the asymptotes will become infinity only because anything divided by 0 is infinity. So there are infinite number of asymptotes here. There are infinite or 0 number of asymptotes it is giving. So for circle, what happens is most of the time you end up in getting the wrong answers here. So don't calculate these asymptotes and all those things. Reason is that this is giving you a ridiculous result. P minus Z is 0 means anything divided by 0 is infinity, means once the infinity comes into the picture, you cannot do any other calculation. So just leave that point. So you can see there are, don't write anything about the asymptotes. Actually, you are getting 0 asymptotes here, but it is not so. Actually, you will get infinite asymptotes. Why infinite asymptote means? For a circle, you can draw infinite asymptotes only. For a circle, you can draw a infinite asymptotes, tangents, infinite tangents. Then you calculate the breakaway point. Rule number 4, the root locus will lie between minus 1 and 1. And similarly minus 1 and minus 2. Two poles and two zeros all on the real axis. And it is symmetrical about real axis. So rule number 5, you have to calculate the breakaway point. So to calculate the breakaway point, I will write the characteristic equation 1 plus g of s h of s equal to 0. Then I will write the equation for k. Simplify that in terms of k. So k is equal to minus s square plus 0.9s plus 0.1 divided by s square plus 3s plus 2. S square plus 3s plus 2, like that. So then you differentiate it. Once again by u by v method, you will get 2 points. One is minus 1.368 and one is plus 0.394. That is, out of which this gives you minimum value of k, this gives you maximum value of k. That means one is breakaway point and another is break-in point. Because these two zeros are consecutive, these two poles are consecutive. In between them, the two one breakaway point lies. In between them, there is one break-in point lies. So this is break-in point because it is between these two. 1 and minus 2. Minus 1 and minus 2, it falls between them. Minus 1.368. Whereas between plus 0.1 and minus 1, you will get two one breakaway point which is lying between minus 394, 0.394. So this is a break-in point, top one is a breaking point, bottom one is breakaway point. Then you write the intersection of root locus with the imaginary axis. For that, from same previous for k, so it is k plus 1 into s square plus 3k minus 0.9 into s plus 2k minus 0.1 is equal to 0. So I will arrange the rows array, k plus 1 here, leave this, right next, 2k minus 0.1, and then in the next row, s to the power 1 term, 3k minus 0.9. If you simplify, this multiplied by this minus this multiplied by this, that is 0, divided by this is this one only, 2 into 2k minus 0.1. If you see the values here, one is 2k is equal to 0.1 or k is equal to 0.05. This is one value. Second value is this, 3k minus 0.9 is equal to 0, that is 3k is equal to 0.9 or k is equal to 0.3. So if you put k is equal to 0.3, this term will become 0. If this term becomes 0, the whole row becomes 0. When the whole row becomes 0, that means this becomes a auxiliary equation, this which is put it in the box. So I have taken that as an auxiliary equation and solved. So this is a square term is there, k plus 1 into s square, k plus 1 into s square, and this one is s to the power 0 term, that is 2k minus 0.1. 2k minus 0.1 is equal to 0. That means if you write that, put the value of k as 0.3, so 1.3 s square plus if you put the value of k as 0.3, 0.3 into 2 is 0.6, 0.6 minus 0.1 is 0.5. So is equal minus 0.5 divided by 0.3. If you simplify s value, it is plus or minus 0.6j you will get, plus or minus 0.6j. That means when the value of k is 0.3, the root locus cuts the imaginary axis at s is equal to 0.6j and s is equal to minus 0.6j, one at the top, one at the bottom. And then I have plotted this curve between 1 and 0.1, plus 1 and minus 0.1, there is one breakaway point. That breakaway point is 0.394. So the root locus starting at plus 1 will come to that breakaway point. Similarly, the root locus coming from 0.1, minus 0.1 will also have to come to that breakaway point. After they meet, they cross over. They cross over like this. And they cross over the imaginary axis at 0.6j minus 0.6j when the value of k is 0.3. Then it moves further and it comes to a break-in point. This break-in point is minus 363. So there they come and meet. And once they meet, one root locus has to go to 1, 0, that is minus 1, and another root locus has to go to minus 2. So the two root locuses end like this, and actually I have not drawn it properly. It is perfect circle. The diameter of the circle is between plus 0.394 to minus 1.363. If you add it, it will become around 1.8 nearly. Total diameter is 1.8 units. 1.8 units means radius is 0.9 units. So it will cut here and here. Partly it is on this side, partly it is on this side. That means the interpretation of this is, if the value of k is 0, the one of the pole is on the right hand side. So system is unstable only. As the value of k goes on increasing, this starts moving towards this starts moving towards this. But still it will be on the negative side only. So hence this is on the positive side only, hence the system is unstable. But when the value of k becomes equal to 0.3, the root locus comes on the imaginary axis because it cuts the imaginary axis here and here. That means the system becomes limitedly stable. Originally, when the value of k is 0, system was unstable. When the value of k becomes equal to 0.3, the system is limitedly stable. If the value of k further increases beyond 0.3, say 0.4, 0.5, 0.6, 1, 2, 3, 4, like that, up to infinity, the root locus will come on left hand side. That means it will become stable. So if the value of k is less than 0.3, the system is unstable. 0.3, it is stable. If the value of k is more than 0.3, it is stable. Is it clear? So here we have completed this particular chapter. So today we'll take a break, and from Wednesday onwards, next Wednesday, I will start the frequency response analysis. That is, in that there are three plots. One is polar plot, one is Nyquist plot. Nyquist and polar is same only. Modification of the polar plot is Nyquist plot, and Bode plot, which is logarithmic plot, it is altogether different, but the principle remains same. We'll take a break now. If you have any question, you can ask me now. If you have any difficulty in root, you have to solve number of problems here. See, all of these rules, whatever you are calculating, they are very simple. They are arithmetic equations. There is nothing more to study there. You can easily calculate all the rules, but the interpretation of the rules requires a practice. So you have to start taking our own solved problems, and without looking at that, you can plot it. You have option to plot it on the graph sheet also, plain graph sheet. But here, remember, we have a limited number of graph sheets available in the main answer sheet. So there is one logarithmic sheet is there, and one so what is that?
Already notes are put up. Already notes are put up.
Yeah, already notes are put up in the class. You can go through the class. ABCD classroom. In the ABCD classroom, the notes of the class are already there. Route service criteria and root locus. Both notes are we have posted. This is what is the question. So what you have to do is take up the same problem which we have solved.
Class at 1. We have class at 1.
What class?
After
Which you have a class at 1 o'clock?
this, there will be no class.
For us, we are not taking the class today. The class ends today only. And then the next Wednesday only we'll meet. Remember, one thing is, when you solve the problem, you take the solved problems first, whatever I have solved so far. Same problem, without study them first, and without looking at them, try to draw them once again and interpret them properly. Then you take some unsolved problem from the book where the solutions are already known. In Nagarath Gopal, he has given solutions of all the problems in the appendix. So you take any problem, or other books also, you take the solved problem of other books also. Without looking at them, you solve them. And then you try to compare your results with the solution. Then only you can see, if you try to solve 4 or 5 problems on your own, you will develop that competence, and that competence is required. So what happens is, for rules, everybody can do that rules. There is nothing is there. Suppose you get a big problem of full 20 marks. If the full problem of 20 marks is there, in that case, solving the rules will have not more than 8 to 10 marks only. But the plot and interpretation of the plot is the major part. 50% or even at least 40% are marks reserved for that. If you don't do that properly, you will lose those 40% marks, 40 or 50% marks. So you have to have a practice. Even the simple problems are also quite tricky. So in last so many years, what I have seen is, almost all the students calculate the rules perfectly all right. But when it comes to drawing the plot and interpreting that plot, very few people do it properly. And that you have to take care, and practice is the only answer for that. Even if I take 100 problems on this, it will not help you. You have to do on your own. Unless you do it on your own, you cannot solve it this way. So I will take a break today.
This is the problem. Where
See,
student-
yeah, here I have not done fully. You try to solve it.
This is also one of the
This is where one of breakaway point finding that decay by ds equation solution. There also most of the students do the mistake. So I have here I have not solved. So you solve it by actually differentiating and finding it. So here I will take break today, and any questions are there?